Okay, so for our next set of problems here, we have to add or subtract the polynomials, which means that we need to identify like terms and add. So I see here that I have a negative 8x to the third power. I have a negative 7x to the third power over here. They're like terms because they both have an x to the third power. I see here I have a x to the fifth power, 3x to the fifth. That has a like term with negative 9x to the fifth power. They both have x to the fifth power, so therefore they are like terms. Finally, we have a negative 2x to the second and a 6x to the second. They are both like terms because they have x to the second. So I have three symbols there. I'm going to end up with three terms after I'm done combining. So we have a minus 8 minus 7. That gives us a minus 15, x to the third power. We only combine the coefficients, and then we have a 3x to the fifth plus a minus 9x to the fifth. That gives us a minus 6x to the fifth. We have a minus 2x to the second plus 6x to the second. That gives us a 4x to the second. So the only other thing I would want to do here is rewrite this in standard form, which means we start with the highest exponent and go down in a descending order. Let's look at our next question. Our next question, same deal. We have to subtract this time around, and we have to identify like terms. The big difference between this one here and the last one is that we have to start this one off by multiplying in a negative. When there's a negative on the outside of parentheses, we have to distribute the negative to each term. Distributed, I've got basically this whole trail of terms that I need to identify like terms. And I see here negative 14mn to the third has a like term with 6mn to the third. They both have the same exact variable and exponent. And then over here we have a 7mn to the third as well, same variable and exponent. Over here we have a 2n to the fourth and a negative 3n to the fourth, same exact variable and exponent, n to the fourth. Over here we have a n to the third and an n to the third. Those terms both have n to the third, therefore they are like terms. So let's go ahead and combine here, starting with the terms that have mn to the third. Minus 14 plus 6 gives us a negative 8, and minus 8 plus 7 gives us a minus 1mn to the third. 2n to the fourth minus 3n to the fourth gives us a minus 1n to the fourth. Minus 4n to the third plus 9n to the third gives us a plus 5n to the third power. Let's look at our next problem. We have to multiply the polynomials. And what we have to do with this question here is distribute the term on the outside of the parentheses to each term on the inside of the parentheses. And so we're going to start off with multiplying this 2x to the fourth y times 5x to the fifth y to the second. We have to multiply the coefficients. 2 times 5 is 10. And then x to the fourth times x to the fifth. When we multiply the same base, we add the exponents together. That gives us a x to the ninth power. And then we have a y to the first times a y to the second. That's a y to the third. Multiplying again, we have a 2x to the fourth y times 4x to the third y to the third. Multiply the coefficients. It gives us an 8. 2 times 4 is 8. X to the fourth times x to the third. We have the same base multiplied, so therefore we add the exponents together. Y to the first times y to the third. Multiply, same base, add exponents. All right, so our next one, we have a negative 3x times 2x to the fourth y. We have to multiply the coefficients. So negative 3 times 2 is a 6, negative 6. And y to the x to the fourth times x to the first is an x to the fifth. And there's no y there. So y is included in this whole multiplication, so we have to include it again. Tack the y on in the end there. Now we have to multiply the last term, so we have a 2 times a 6, which is 12. And we still have the x to the fourth y multiplied. They don't have any other bases to multiply, but we'll still tack them on in the end there. Look at our next problem. On this one here, we have to multiply x plus 3 to the second times 4x plus 1. What this means is we have to start off by expanding and multiplying. We have to expand x plus 3 times x plus 3. The power of 2 tells us that we have to multiply x plus 3 times x plus 3. And so we're going to multiply these binomials to start. I'm going to multiply with the x first. So x times x is x squared. X times 3 is a 3x. Now I'm going to multiply the 3 in. 3 times x is a 3x. 3 times 3 is 9. So from here, we have to combine some like terms. We have 3x plus 3x is a 6x. And now we have a trinomial times a binomial. That's some more multiplying. And I'm going to start off with multiplying the 4x over. I like to go from the smaller to the bigger. So you could go from the other side. You could go from the left to the right if you wanted. I like going from the smaller to the bigger here. So 4x times x squared. So 4 times 1 is 4. X squared times x to the first is x to the third. 4x times 6x. We have 6 times 4 is 24. X times x is x squared. 4x times 9 is a 36x. Now we have to multiply the 1 times each one of these terms. And that's pretty easy. 1 times anything is that thing. So 1 times x squared, we have a x squared. 1 times 6x is a 6x. 1 times 9 is a 9. So let's go ahead and combine like terms. We have 24x squared and 1x squared. That gives us a 25x squared. We have 36x and 6x. That gives us a 42x. And that's it. Next question. We have to factor out the greatest common factor. So what we want to do is we want to break this thing apart, this polynomial, and figure out the factors that each term has in common and circle them. So what I've done is I've just gone through and I've broken each term apart into its prime factors. So I'm going to go through each term and identify the same factors in each. I have a 5 in each. I have another 5 in each. I have, let's see, how many y's do I have in each? I have 3 y's in each. So 2 of the terms have more y's than that, but this term, the last term here, only has 3, so I can only circle 3. And I have 2 z's in each. Once again, we have some of these terms that have more than 1 z, more than 2 z's, but the last one only has 2, so we can only circle 2. And this last term only has 1x, so we can only circle 1x in each. So the largest common factor that we can pull out of here is a 5 times y times y times y times y times z times x. That's a 25y to the third z to the second x. And what I am remaining with on the inside of the parentheses here is everything I didn't circle. We factor out the 25y to the third, z to the second x. We're left with y to the third, z to the second x for our first term, plus 2z x for our second minus 3 for our third. Remember that if you're feeling uncertain, you can always multiply back in your greatest common factor to see if what you have done is correct. Let's factor the trinomial with leading coefficient 1, degree 2 and leading coefficient 1. What we're asking ourselves here is what two numbers will multiply to give us a 48, and the difference between them is a 2. 6 times 8 is a 48. Difference between them is a 2. We get that 48 by these last two multiplied here. First, the n squared, we get that from n times n. So what signs do we give here? The 8 needs to be a negative, and the 6 needs to be a positive in order for this to work out. Remember that factoring is the opposite of multiplying. And if I wanted to check this, I could multiply these two together to see if what I found is correct. So in red there, that is the confirmation that what I found is correct. You guys don't have to do that, but it's a good check for yourselves. Okay, next one we have to factor the perfect square trinomial. A perfect square trinomial is when we have essentially a trinomial that can be factored into two of the same exact binomials. 4b squared, that's a 2b times a 2b. 49, that's a 7 times a 7. So our first slot gets 2b and a 2b. 2b times 2b is 4b squared. The next slot here, we get a 7. 7 times 7 is 49. Now what signs do we need here? I know that the outer 2 and the inner 2 combine to give me that middle term of negative 28b. I know the outer 2 is a 14b, and the inner 2 is a 14b as well. How do I get that negative 28b? Both of these 14s need to be negative. So I need a minus and a minus there. Once again, you could check your work by multiplying together, but really in the end, all we need is this here. And I saw some folks on the test, they wrote 2b minus 7 squared, which is just fine. Factoring the difference of squares. Well, this one is a situation where something times itself. 3x times 3x is 9x squared, and something times itself is 4. And we factor into almost the same exact binomial, it's just we have different signs. So we have 3x times 3x is 9x squared, and 4 times 4 is a 16. One of these is a minus, one of these is a plus. We have no middle term because of that. If you were to look at the outer 2 and the inner 2, that would give you a 12x and a minus 12x, which gives us a 0. There's no middle term here. In the end, though, remember, all we need is the factored problem. Let's look at another one. We have to factor the trinomial with degree 2 and leading coefficient greater than 1. That gives us multiple possibilities. 3 is 3 times 1, thankfully 14 now. That could be 2 and 7, 7. It could be a 14 and 1. Let's see which one it is. Okay, so I've decided to focus on the 3 and the 1 and the 2 and the 7. The first thing I notice is that there's a typo in the question. And so I've changed our middle term to be a negative 13. So let's see how we can come up with a negative 13. I have my two options here, the 3 and the 1 here, the 3x and the 1x here, and the 3x and the 1x here. And I flip the 7 and the 2. So how do I determine which one is correct? I have to look at the outer 2 and the inner 2 to see if they will give me the middle term. Okay, so I see the one on the left, there's no way that the 21x and 2x could give me a negative 13x. That's out of the question. But the next one, I could get a minus 13 with a minus 6 and a minus 7. So that gives me this correct factorization.